Hello, students. A couple questions came in by email, so I thought I would address those. And let's see here. Question 6. I guess honestly 6 or 7 maybe. Let's see here. What's the difference between A and B? Oh, that's the single digit one. This is without using a calculator, justify whether it works. Okay. We can do, I mean, these are similar to what we did in class, where we were looking to find with the two theorems, theorem 4.1, which says if it divides a number, it divides any multiple of a number, and theorem 4.2, which says if it divides a number and divides another number, and you add those numbers together, it divides the sum. So I think that's probably the biggest piece in this one. Let's see. There we go. So let's see here. We could do any part of these. Really doesn't matter here. So part A says, does 5 divide? We'll just do, does 3 divide? So very similar. Does 3 divide 2 times 3 times 5 times 7? And so again, if you look over here and you can see a number that 3 does divide, like 3, and everything else is just a multiple of it, that's theorem 4.1. And so does 3 divide this? Yes. Why? Because I can show that 2 times 3 times 5 times 7 is equal to 3 times some number. So 2 times 3 times 5 times 7 is equal to 3 times some whole number. And if you're looking for which whole number it is, here's a hint. It's got to have a 7 times 5 times 2. And that's it. So there's the reason why if you need the full definition, but it just says you have to justify your answer. So I would definitely say this one is true. 3 does divide this number. And I can see it's 3 times some other whole number. So definitely true on that. What would be different here? If I put like a plus 5 at the end of this one, right? Well, then 3 does divide the first term, which is right here, plus, so it does divide this one, but it does not divide the second one. So I would have to say that it does not divide that whole number. Then it looks like they kind of get down into like this one, 4222. I mean, just do what we did in class, right? Right is 4200 plus 22. 7 divides this, 42. So it divides 4200, and 7 does not divide that second one. So you can see why that one doesn't work. And over here, yeah, we just have prime factorization. So 6. 6 is 2 times 3. Does that divide 2 cubed times 3 squared times 17 to the 4th? And so do you see 2 times 3 over here on the right-hand side that you could say, oh, it's 2 times 3 times a bunch more stuff. And hopefully kind of pick up and say, okay, I definitely have a 2 and a 3 here. So I could write this as 2 times 3. And everything else over there would be a 2 squared times 3 to the 1st times 17 to the 4th. So there's your number that you're multiplying it by. There's a 2 times 3. It definitely divides. And the rest of it is good to go. So yeah, it goes back a little bit to exponents, I guess. If you're trying to see if something divides, it will divide perfectly if what you want to go in is smaller than the exponent. So for example, 2 squared would divide 2 cubed. That would be kind of a quick one. But if I try to say, does 2 to the 5th divide 2 cubed? The answer would be no, it does not. Because nothing I can multiply the 2 to the 5th by to get to 2 cubed. It'd have to be the other way around. Okay, there's that one. Let's see here. What else do we have? Yeah, so exponents, I think I just showed the exponent components. If you need to factor, again, that's a skill from a prior class, but that's why we have the algebra prerequisite to make sure, hey, we got to have that skill as we come in. So for example, it says justify each of the following statements. So the statement is saying justify it. You can say, and like in part C, it says 2 to the fourth does not divide this. Okay, that's fine. But we'd have to show that it divides one of them, but does not divide the other. And that's probably where you would want to factor a little bit here. Let's see here. B, same thing. Just do some factoring if you need to. So let's see here. Let's take a look. 13. It says 13 does not divide 2 to the fourth times 5 cubed times 26 plus 1. It says it does not divide. Well, if it does not divide, I can see over here it clearly does not divide the number 1. In order for it to not divide this whole thing, I need to show it does divide the first one. So take a look. I see a 26. 26 is 2 times 13, which means this whole thing could have been rewritten as, here we're going to combine our objects. This would be 2 to the fifth times 5 cubed times 13 plus 1. So that's really what we're asking. And then from this piece, you could say, well, I know 13 does divide here because it is a factor, plus 1, and it does not divide here. So by 4-2b, it does not divide. Outside of that, yeah, just look for your factoring. If you see a 3 to the fourth, and on one side you see a 15 to the fourth plus a 6 to the fourth, just do a little bit of factoring. So what does that mean? On this side, you could rewrite this as 3 times 5 to the fourth plus 2 times 3 to the fourth. And then using our properties of exponents from chapter 3, 3 to the fourth times 5 to the fourth plus 2 to the fourth times 3 to the fourth. Okay, those kind of distribute. Remember, exponents do distribute across multiplication and division. And then look for common factors. So I have a 3 to the fourth and a 3 to the fourth. My final answer would be 3 to the fourth times 5 to the fourth plus 2 to the fourth. And again, this is just some number. So does 3 to the fourth divide this big whole thing? And the answer is yes, because it divides the first part. So it divides any multiple. So that's how we can take care of question 7. Let's see here, question 8. Yeah, question 8. Let's see, I guess I'm not sure which part, but all of these you can just break it down into 2 components like we would have done in class. I'm not sure which of these would be. Oh, it says mentally classify them as true or false. All right, well, again, I have to write a little bit something out because I can't just shine a light inside my brain and have it turn on so everybody can see what I'm talking about. Okay, but here we go. We're mentally doing these. All right, so how would I mentally do these? So right here, I would say 12 definitely goes into 24. And so what I have is 24, 0, 0, 0 plus 13. And I would say, yes, 12 divides here, but it does not divide there. So I would answer this one as false. Okay. Very similar to part B. It just says 24,000 plus 36, and 12 divides 36. So this one I would have marked as true. Let's see, was there a particular part? Let's see. Let's see what the student question has said. Part F. Okay, well, part F. Yeah, I don't think we'd be able to do this one on a calculator. Let's check and see. I'll clear everything off here. Let's go to Desmos. Desmos.com. We'll jump to the graphing calculator and we'll say 46 to the 10th power. Yeah, this thing is 16 digits long. My calculator does not show everything. So if I say this divided by 23, I cannot tell whether it divides evenly or not. There's not enough digits here for me to tell. Maybe it looks like it does, but again, this is times 10 to the 15th. So I'd have to move the decimal place 15 times to get that out of the way, which is why calculators aren't great for everything. We can actually figure this out on our own using what we did in class. So let's see here. 23. Does 23 divide just 46? Ask yourself that question. Question mark. And the answer is definitely true. And so now if it divides 46, what do you know about 46 and comparing it to 46 to the 10th, right? And remember that if it divided 5, then it must divide 5 squared because 5 squared is simply 5 times 5. So how does 46 compare to 46 to the 10th? So that is my little tip on that one. Let's see here. Question 11. Notepads. Oh, yeah, this one with notepads. How many notepads were sold? So we know we have two numbers that multiply together. It has to be between $1 and $2. So if you're trying to figure out how to do this one, yes, you could guess and check. It's not a great strategy, especially on an exam. You're never sure exactly how long it's going to take. But instead, what I might do is try to break the numbers down. Like when I look at the number 3145, and maybe I'll measure this in cents instead of dollars, so it's a whole number. What divides into this number? And I can definitely see that 5 divides into this number. And okay, so 5 divides in. What does that tell me? Well, I have 5 times something that has to give me 3145. So that gives me some factors. And so if I need to, you can go up and say, well, wait a minute. One of the nice properties was if I have 3145 and I divide it by 5, I actually get the other factor right there. So the other factor is 629. Well, that would mean I'm selling 5 notebooks at $6.29, or I'm selling 625 notebooks at 5 cents each, but neither one of those match up with what we're actually doing. So we're going to need to do a little bit more. And what we need to do is say, well, something else has to go in here into 629. And I think that's where we kind of don't have a ton of other options in terms of like what else could we check? We could check our divisibility rules. So 629. Let's see here. I could add all the digits to check for 3. So 6 plus 2 is 8. 8 plus 9 is 17. Okay, so 3 is out and 9 is out. So those are out. Look, last digit. So any other evens are out. So 2, 4, 6, all of those are out, right? Let's see here. I guess we could try 11s. So up and up would be 15, down would be 2. The difference is 13, so 11 is out. What else? 5 works. That's great, but it doesn't really do us much more after that. So I'm looking at this number, trying to figure something else out for this number. Let's see here. 630 is a really nice number. 630 minus 1, but 7, the number 7 does divide into 63. 9 times 7 is 63. So it works here, does not work here, which means 7 is out. Okay, so as I keep kind of going up, 7 is out, 11 is out, all the evens are out. So I'm just kind of looking for numbers then that kind of narrow it down. So I have 13, 3 is out, so I know 15 is out. Don't even bother checking it. I have 17. So what I would do is then I've just kind of narrowed the focus down to see, hey, can I just check a couple other numbers? Let me try 13. So I would come over here and say, let me try 13. That one didn't work. 17, and 17 went in perfect. So it took just a couple options here. My divisibility test helped narrow it down. And I could see, okay, so I do have one other piece. I know this could be 17 times 185, and that equals 3145. So I'm either selling them for 17 cents each, or I'm selling them for $1.85, and that actually works. So there you go. If you needed to, you could, once you have the 17 times 185, you could actually break this down a little bit, because 185 also has a 5 in it. So if you were to break that down just a little bit further and say 185 divided by 5, and that's 37. So what you really have here is you have that 3145 is equal to 5 times 17 times 37. And let's see here, does that check out right up here? 5 times 17 times 37, 3145. So when you look at this, they really don't have a lot of options. If you're kind of saying, hey, I need to make two of these multiply together. If you multiply the 5 times the 17, what does that give you? 50 plus 35, so 85. 5 times 37 is 185. So there's not a ton of other options that would work. The next one up, it looks like I could have 37 times something. So 37 times something. And if I check that in Desmos, let's see here. So if I do 3145 divided by 37, gives me 85. Oh, see, so that's now I know like I could be selling these for 85 cents each. I could sell 37 of them for 85 cents. 17 for $1.85, 5 of them for $6.29. So if you look at all the possible factors, it's like you pick one of the numbers to be like how many. So I have a 37 here, I have a 17 here, I have a 5 here, and then you look at the pairs, right? So if I do 5 times 37, well, that gives me a 185. 5 times 17, that gives me 85. And 5 by itself, 17 times 37 gives me 629. So I have all my pairs out there, and there's simply nothing else that we would do. And technically, we could have one and 31.45. So I sold one notebook for $31.45. That's possible, but again, it said they had to sell between $1 and $2. All right, let's clear those out. And 14. The number is divisible by 8 if and only if it's divisible by 2 and 4. Yeah, so this is similar to what we did in class. In class, we talked about is a number divisible by A and B. I didn't use this exact number in class. I did use something slightly different. I said a number is divisible by 12. So n, what do I want to say? 12 divides n if and only if that number is divisible by 2 and 6. Okay. So what do you think? If a number is divisible by 2 and by 6, then it must be divisible by 12. Okay, now you're trying to say true or false. So if you can find one time where it's true and the other where it's false, you have a nice false statement. You violated it. So let's start over here. Can you think of numbers that are multiples of 2 and numbers that are multiples of 6? And if you need to, come up and make that sequence like we saw in class. 0, 2, 4, 6, 8, 10, 12, dot, dot, dot. Over here, we'll do the same thing. 0, 2, 4, oops. I'm going to do it 0, 2, 4, 0, 6, 12, 18, 24, dot, dot, dot. And then you look for what do they kind of have in common? Are there numbers where the and statement means both of them have to be true? So yeah, 0 works for both. Then I have to cross off 2 and 4, then 6 works and 6 works. Cross off 8 and 12, then 12 works and 12 works. So if you look over here, these are the numbers that are going to satisfy both of these quantities. It would be 0, 6, 12, 18, and so on. And the question is, if you pick any number in this set, does that mean 12 will divide that number perfectly? And so you could pick 0, in which case you would say true. You could pick 12, true. You could pick 24, which is coming next, true. But if you happen to pick 6, you could not say that 12 divides 6. So that would be false, and you have one counter example. And that's all you need to show that something is not true. So what I talked about in class was make sure they do not have any common factors. If they have common factors, it isn't going to work. Let's see here. Got a little bit of MCs, it looks like. MC 3A and 7. Okay. Jim wants to see if a number having 8 or fewer digits is divisible by a number D. He types the division in on the calculator and the display reads 32 right on the nose. This is probably more of a understanding what calculators are doing type of question. So if I said, let's see here, 7 divided by 8, okay, I get this number. So when I ask myself, does 8 divide 7? Then we kind of have an answer right here as to whether or not it does. Notice the difference if I put something like 3,240. And I say, does that divide 8? When I type in that and I divide, I get 405 right on the nose, right? So you can tell this does divide, and you could say 8 times 405 is going to get you 3,240. Okay. So if it doesn't go in evenly, for example, what if it says something like this? 3,242 divided by 8 gets you here. Is 3,242 divisible by 8? So that's kind of the question that's being asked here. So Jim types in a number. They're not even going to tell you what the number is, but they're going to tell you what you got on the calculator. And the calculator says 32. So based on that information, are you able to conclude, does D divide N? And make sure you give a why or why not. And then they give you another one right afterwards that says, hey, what do you do if the display doesn't give you a nice whole number? So a couple options there. I think it said 3A and 7. Let's take a look and see. 7, enter any 3-digit number in a calculator. Okay, repeat. Got it. Then divide the number by 7, by 11, and by 13. All right, well, let's go try it out. Okay, so here we go. Any 3-digit number you want. So let's say 537, then type it down again, 537. Got it? Now what you want to do is divide by 7. Oh, and look at that, it went in evenly, right? And then we'll do that again. So 76791. This time it says divide by 11. And it went in perfectly again. Okay, that's kind of nice. So now type in the last little piece, which will be, oops, that thing's having a little bit of an issue with my display pad, 6981. And we're going to divide by 13. And you end up with 537. So I can divide by 7, by 11, and 13. And it turns out I actually end up with 537 when I started with 537, 537. So when I did my division, I came back to exactly what I had at the beginning. And so that, of course, seems a little strange, probably. So what we're going to do is do a little bit of an investigation. Like, what the heck? So just jot down what you see. What did we start with? What do we know? So I picked the number and I wrote it down, 537, 537. Then I took that number and I divided by 7, 11, and 13. Okay, so that means this has to equal 7 times 11 times 13. Okay. Times something. So I divided by 7, I got a big number. Take that and divide by 11, I get a smaller number. Take that, divide by 13, I get an even smaller number, but it tells me what to write down, and it says write down 537. Well, that's pretty weird. So each side has a 537. So if you wanted to, what you could do is you could divide both sides by 537 because they're now equal. So if I divide this entire side by 537 and divide this entire side by 537, the 537's over here, one's multiplied, one's divided, that cancels out. Over here on the other side, how would I rectify this? This is really 537. Oh, it's really 537,000 plus 537. And we notice 537 divides both of those. So it does go in evenly. And this right here would be 537 times 1,000. And this would be 537 times 1. So if you're kind of grouping all those 537s together, this is the same thing as, oops, one extra zero there, 1,001. And then if you take a look at just the number 1,001 and you try to connect it back to what you had up here, you might see something that's pretty interesting. Let's take a look. So if I said, well, what is 1001 divided by 7? And I get the number 143. So 143 divided by 11 turns out to be 13. So this fancy looking 1001 is actually 7 times 11 times 13. It's not prime. It kind of looks like it is, but it's not prime. Okay, well, that pretty much takes care of this section. And I think I answered all the questions. Yep, I think I got all of them. All right. So that wraps it up for me on this one. Thanks for sending the question in. Keep them coming. If you're stuck on anything, let me know. We can meet up in Zoom. I can do another one of these videos, or we can meet up on campus. I'm on campus every day. All right, everybody. I'll see you soon. Off you go.